It's really good to be here. I've been to India 3 times now. This is my 3rd. But it's been 9, 10 years since the last time I've come. And so I've never been to Hyderabad. And I've been super impressed with the number of just all the exciting projects that are happening here. When I came to Syfy 2009 and I spoke at Kerala, there were 700 people at the conference, and I think about 50 of them knew what Syfy was. So that was great, a lot of new people, very exciting. But here, it's clear I've come and I've just seen numerous really deep and interesting projects, and clearly Python's taken root here in Hyderabad and elsewhere across the country. So that's very exciting. I'd like to thank Ram and others and the organizers of PyCon who had me come. So I'm going to talk a little bit basically about how open source can help you change the world, and give you some examples of how the world's been changed over the past 20 years because of open source that I've had the opportunity to be involved with, and hopefully inspire some of you to take your projects and your passions seriously and do something with it, and connect with the people next to you and build teams and build projects and export those to the rest of the world, because there's still so much to do. It can be a little daunting. You come to PyCon, you look around, you see hundreds of people, and they all seem smarter and more experienced and have more to offer than you do, perhaps, so you think. But everybody starts somewhere. Python started in 1991, and before Guido released it to the public over the December period in early 1990, 91, nobody knew what Python was. We were all stuck using Perl. We were all stuck using Tickle, TCL, or Bash, or C if we wanted to hurt ourselves and shoot our feet off. But then Python came, and people like me who are scientists could use it, feel comfortable with it, and then start getting excited about extending it. And that's the journey I've been on for a long time. This is sort of a history of all the scientific packages, the data science packages, and it's interesting because a lot of people usually come and they see all of this. They don't really understand the history where it comes from. Not that you have to know the history, but sometimes it helps explain why things are the way they are. Sometimes it's really not designed, it just sort of emerged and evolved, and it's helpful to understand that, because then you can recognize where you can plug in, and you can make a difference and do something important. Some of you may know me for Syfy. That was the first thing I started working on when I was a young graduate student at the Mayo Clinic. Syfy is a collection of libraries, and with a few colleagues, we released it in 2001. But since then, it's succeeded because of the 652 contributors who came to Syfy and added their work and effort and knowledge and passion to this project. It's had 99 releases. The 1.0 just came out, I think, a year ago. Some of you might know me from Numpy. Numpy came after Syfy, actually, and it did because I was so excited about Syfy, and I didn't like seeing Numpy numeric and NumArray. There's a split happening. I may talk a little bit more about that a little bit later. But there's a split happening, and I didn't like it. I was concerned that my beloved Syfy would get lost underneath all the packages that were being released for this new array object called NumArray. So I spent a bunch of time. Effectively, I gave up my tenure position, where I had a tenure track position, and I knew that they wanted me to write more papers. But I knew that writing NumPy would be much more impactful and have a bigger impact. Didn't know exactly that it would have this big of an impact, but I knew that more people would care about it. And so I spent the time doing that, not writing as many papers. But I'm glad about that, because it unified the fledgling Python community around data science and ensured we could build an entire ecosystem around a common array concept. Now that currently, actually, we have a lot more array objects. That was the case up until about 2014. About 2015, 2016, now come TensorFlow, Torch, MXNet, CNTK. Everybody's found Python, and everybody's written an array object for Python, and now we have the same problem. And so there's sort of new opportunities to try to help solve interoperability. But NumPy has succeeded again because of the large number of contributors who have come to the project. 694 as of yesterday, I could see on GitHub, and 144 releases. Some of you might know me because of Anaconda. So I'll tell a little bit in the future why I care about business and starting businesses. So I started a business called Continuum Analytics. We renamed it to Anaconda in 2015, and we basically built a packaging system, primarily because Syfy, when I first released Syfy, most of the effort was actually in distributing Windows EXEs, Windows installables. And in many ways, Syfy is a distribution of Python masquerading as a library. And it took a little while to figure that out. But eventually, that's how a scientist doing MRI and ultrasound got pushed into distributing software through a system like Anaconda. But it's interesting where life will lead you if you keep focusing on trying to help people. If you haven't heard of Anaconda, you're missing out, especially if you're using Python and using a lot of packages together. So check it out. You can download Anaconda. It's free. Anaconda is an open source community package manager. Some of you might know me for NumFocus and PyData. At the same time that we created Anaconda, I got together with a few of the open source heroes of many of yours, people that founded Jupyter, Matplotlib, Scikits, NumArray, and we started a nonprofit at the same time called NumFocus. The purpose of the nonprofit was to be a home, a place, a legal home for the packages that otherwise were just kind of nebulous. Wasn't clear. There was somebody who owned NumPy.org, somebody else owned Pandas. How do we bring those together and actually have a place we can call home? And now there's a board, a new board was just elected in 2018. These fine people are serving for 2 years, I think is the period they'll serve. And then the PyData ecosystem, we started basically trying to understand how to bring Python to big data. In 2011, Hadoop was all the rage, and that's all you heard about. And everybody was, sort of the rise of Java once again. I actually call it the 40-somethings who bet their career on Java really loved the fact that Hadoop was going to get it back for them again. And so they brought it back in the industry in a firestorm. Hey, let's all do this again. We saw that we went to a big conference, the Strata conference, and I noticed at that Strata conference, nobody was talking about Python. None of the commercial vendors were talking about Python, but all the talks were using Python to do data analysis. Even back then, Python was still very popular for data analysis, and so we said we got to fix that. And PyData ecosystem was built to sort of help rally the energy that existed. It shocked me how big that energy was. We just had a first meeting at the Googleplex. Google hosted the facilities. Then we had one conference in New York, another one on the West Coast, and it just bloomed from there. And now there's conferences, 15 conferences this year all over the world. And they're grassroots, organized just like PyCon India is organized. I think there's a PyData Delhi, and I think a PyData Bangalore. There may be additional ones as well. So the PyData conference series is something super excited about. Some of you might know me for work on projects that at Continuum, we kept innovating. We kept trying to create better tools to help people do data analytics in Python. We knew we wanted to scale Python to GPUs and multi-core machines. We needed to scale Python to kind of answer the question about, well, if I want to run on multiple clusters, I have to use Java, right? I have to use Hadoop. I can only use Spark. So we wanted to answer those questions and provide facilities for that. So Numba and Dask were created, and those teams did a great job in helping to produce a compiler for Python, for a subset of Python, a compiler for NumPy array-oriented Python. I gave a talk on Numba in PyCon in the US in 2013, I believe, when we first released it, and since then it's been growing and getting better and better, and Intel's added some things to it, and it's actually a very nice tool right now. And a lot of people are starting to depend on it for their fast modules that they're distributing. It's a great thing. Dask is really your answer if you're forced to use Spark. You can sort of start using Dask, and you'll be a lot happier. Bokeh, Python visualization, PyVis, HVplot's a new one, but the goal was to bring visualization, browser visualization. So Matplotlib is a venerable and very useful tool for static plotting, primarily, even in the web. We wanted to create interactive plots, dashboards, make it really easy for a Python developer to write code, write their scripts, and then produce visualizations and dashboards in the web. So that was Bokeh. Jupyter, a fantastic project. Many of you know about that. Jupyter Lab was I had the chance to organize the team that coordinated with Brian Granger and Bloomberg to build the next generation of Jupyter called Jupyter Lab. And that is now continuing on, and it's a fantastic project, very excited about it. So along the way, I've had some fun. I've met, worked with, interacted with some really, really great people. It's amazing what can happen as you sort of put your heart and your mind to just doing good. I am humbled and grateful at the kind of impact that work has had. And it's not just my work. It's the work of all the people that came together to do this work together. But the impact of Numpy and Syfy very early on, it was exciting to see that it's helping physicists. I don't always know what impact it's having. I'm often very surprised. I hear people tell me later what happened and what they did with it, and it's very exciting to see. Sometimes that is one challenge we face in open source, because constantly people are asking us, well, why should I keep supporting this? Is this good? Is this something useful? And it's really hard to tell because people are using it, but they're not necessarily writing home. Nobody sends a postcard. Nobody sends information. And one of the challenges is how do we keep funding this? How do we keep working with this? How do we keep benefiting the people that are maintaining this if nobody knows it's getting used? That's a typical tragedy of the commons problem, and it exists, and it has existed for many, many generations in human organizations. But it's still a problem we have. It's a problem we have with open source. And I'm interested in the solutions that you're going to come up with to that problem. But we've been helping physicists with these tools, helping finance with these tools. In 2007, 2008, the United States had a big financial crisis, basically due to over-speculation, but also due to the fact that people didn't know what their trades were. They didn't understand their exposure to counterparties. Since 2009, 2010, Numpy got used a lot by pretty much every investment bank and every hedge fund. And when I sort of realized that, I had the chance to consult with a few of them and see what they were using them for. And they were using them to do things like improve their credit risk exposure. Regulators would come in and said, you've got to now fix this and understand your exposure to other counterparties. And so they would, using Numpy and Syfy in often interesting ways, ways that I didn't expect, they would be using that to make better investment decisions, get more information, and summarize that information to more people to avoid the kind of financial panics that occurred. So hopefully, we're helping those not occur, not happen in the world. And so, that's the work of community. All of a sudden, a few hundred of us, effectively, have literally altered the course of human events in a very significant way. Powerful way that open source literally changes the world. Recently, I've had the chance to work and interact with the TensorFlow developers and the Torch developers, and been quite humbled by the fact that they basically tell me, oh yeah, we're completely inspired by Numpy. We've sort of built our stuff, and we use Numpy, and we relate it to it. Now they're doing new things, and they're integrating with C++, they're integrating with Lua and other organizations. Chainer is another machine learning library written by my friends in Japan from Preferred Networks, and they have a machine learning pipeline completely on Numpy, and a version of Numpy they call CuPy that works on GPUs. But these machine learning frameworks, which of course everybody's excited about because the promise of what that will do, the nonlinear models and the better predictions we'll be able to make, there's some exciting applications emerging, and that will continue. Even if it's a little bit overhyped, it will continue because there's some real value there. And in many, many areas, we're going to see a lot of advances because people effectively are able to apply advanced math more easily. My goal has always been to put in the hands of smart people tools that let them use their intelligence and get the computer out of the way. Quite often, software systems, data systems, sort of are still in the way. And the person with the intelligence and mostly it's the experience to try to figure out what to do with the data is stuck kind of running through systems that are awkward, or APIs that are awkward, or underpowered. I think the most powerful impact that I'm really grateful for, and the kind of impact you can have as you contribute and deliver in open source communities, is just the grateful users. It's been a thrill to be here and have people just come up to me and say, thank you for Numpy, thank you for Anaconda, thank you for any number of things that they may have used. And that's exciting. It's exciting because at the end of the day, that interaction with somebody, the ability to help somebody else, is going to give you a lot of satisfaction in your life. It's the single, I think, biggest source of confidence, and you can get it by just helping one person. And so I really appreciate those expressions of thanks. I appreciate them because I appreciate getting to know you. I appreciate getting to know what you're doing with these tools and how you're going to help somebody else. Now, if I had time, I'd kind of talk about what I'm doing now. I'd talk about this new company I'm creating, Quansight, that's trying to build and connect companies and communities to solve problems with data. We're working on all aspects of the data science and augmented intelligence workflow. This is going to continue my quest. I got started in business because I want to figure out how to pay open source developers. I want to figure out how to help at least solve or at least contribute to a solution of this tragedy of the commons that occurs and is occurring right now. where millions of people are using Numpy and Syfy, projects I know quite a bit about, and yet they're still struggling to get any maintenance. They're struggling to get any money in order to pay anybody to work on these projects. So again, trying to figure out how to solve that, trying to figure out how to get money to support these important tools so they can be maintained. Quantsite is actually continuing the thoughts. When we started Anaconda, we actually call it Continuum, and Continuum was doing a lot of experiments in the market, doing a lot of experiments to figure out what could we do to serve the world and create products that would help. And we found one in Anaconda, in Anaconda Distribution, Anaconda Enterprise, and that effectively became a spin-out. That's not actually structurally how it went, but effectively, we spun out and grew a company out of this incubation concept. And so with Quantsite, that's what we're doing, is re-establishing that incubation concept so we can spin out additional companies virtually. I'm very excited by Quantsite Labs. I talk more about it, but I'll give you just a brief overview. Quantsite Labs is one answer, getting companies to sponsor a labs activity where you have people who are either new, right out of college, or maybe they're in transition between careers, and they're in this labs effectively to work on open source and get companies to sponsor this labs. And I'm having some success with that. We just started. We're partnering with NumFocus, partnering with Ursa Labs, supporting Arrow. And the work we do is everything around the data science workflow. So NumPy, SciPy, Pandas will support any of those, as well as improve the connection of NumPy to the machine learning libraries, improve data virtualization, improve the foundations of array computing, have a couple of projects in that direction. The other vector we do at Quantsite is we actually prioritize the needs for enterprise. We do have something called the Sustainable Open Source Partnership. So Quantsite Labs is about sponsoring open source with kind of accountability of 6 weeks to 3 months, right? Sustainable Open Source Partnerships is about companies getting what they need out of open source with accountability of up a week, weekly accountability. Effectively, it's a project. But we work with the communities because it's a little tricky to work with open source. It's not like you can just come in and say, okay, I want this done, please do it, community that built Pandas, right? There's a bunch of stakeholders there. They have their views. These projects have their own roadmaps. So we work with the communities to publish those roadmaps and then work with companies to save themselves money by, instead of reinventing the wheel, work with the communities and save themselves a lot of money in many cases by getting features that they no longer have to maintain, or they're really sharing the maintenance of it with everybody else. And then the companies can hire from the community, get support they need, and that model is working pretty well as well. We also host a webinar. It's recorded, so it's on the other side of the world is where we host it, so the timing might be middle of the night for if you're over here. Maybe you don't want to attend live. But you can see all the recorded versions of this webinar on YouTube, on our YouTube channel. Open Source Directions is about publishing and interviewing community members and talking about their roadmaps. Really, it's to broadcast and advertise communities and what they're doing so that companies and organizations with funds can understand what they might save money on by helping to sponsor, instead of themselves doing the work over and over again. I might talk a little about the next project that I'm working on. This is a refactoring of NumPy. This is called XND. It's a very new project still, but it's roughly in alpha mode, but it's ready for developers to start playing with it. We have a gentleman in Japan just used this to port NumPy features to Ruby. Somebody could port them to Java. Somebody could port them to Node. I'd love to see that. XND, its purpose is to take the features of NumPy and make them available in other languages. I've often had that request over the past 10 years. Please, can I have NumPy in Java? Please, can I have NumPy in X? And if you want array computing in lots of languages, this is my answer. XND provides a series of C libraries and then bindings to those other languages. And it takes the concepts of NumPy that worked, generalizes them, and applies them to other languages. Stefan Krah, who is a Python core developer and in Germany, has been working with me on this for about 2 years. And he's very little funding. We really haven't had any funding. We've just been, by hook and by crook, making these features available. So this is part of what I'm trying to fund with Quantsite Labs. The next concept is the unified array interface. Presently, it's one answer to the problem of the split community. We have many, many arrays now between TensorFlow and Torch and MXNet and NumPy. Of course, there's also Dask and Xarray. There's many more kinds of arrays out there. And effectively what I've realized, and many other people have realized, is we have a similar situation today that Python 2 had between strings and bytes. So if you remember that problem, the problem's a little subtle. The problem is that in Python 2, a string and a byte were exactly the same thing. Yet semantically, people would use them differently. So I want a string. I'd use the string, which is also a byte. I wanted just bytes of bits and raw data. I'd also use a string. And so my code was very confused, and nobody could tell by looking at the code what I meant. We have the same problem today in the Numpy land, an array land, because people have uses of arrays where they don't really care. Is it a specific structure that Numpy provides, or is it another structure? Could it be a sparse array? Could it be just an on-the-fly array? Could it be a delayed array? Could it be a distributed array? But you still want to be able to write algorithms on top. Syfy, scikit-learn, higher-level algorithms on top of Numpy want to be able to work, at least as much of it as possible. And we have no way to distinguish those two. People who are using arrays on Numpy are just using Numpy arrays. So we have this confusion between logical arrays and strata pointers of Numpy. So that's the problem. That's the work of UArray. It's still a research project. So don't run out and say, hey, I'm going to use UArray for my project. No, it's a research project. There's other people looking at how to solve this. We're looking seriously at this problem right now and hope to make real progress on it over the next 6 months to a year to help potentially be a place where multiple layers of code can live on top of a common array object. I might want to tell you about my other project. This is one of the possible spin-outs that we're working on. It will spin out sometime next year out of Quanside. It's called Open Teams, openteams.io. You can go there now. You can go there now, sign up. It's still pretty new. It's very recent. I don't announce it much. I'm announcing it here, so people here get kind of a preview of it, or if you're watching this on YouTube, I guess you can get a preview of it as well. Probably will have changed since then. This is a network for open source contributors. Again, we're trying to connect companies with communities, and part of that is organizing communities and helping communities come together and understand how they can impact the world together and find people with common interests or similar interests. So Open Teams is a place you can find other people, you can find collaborators, advisors, you can find you can advertise your skills, you can advertise your availability for contract work, for being hired to do work on the Sustainable Open Partnerships or inside of Quanside Labs. Try it out, give us feedback. It's still very early, still very nascent. We've just been building this slowly in our spare time. But check it out and give us some feedback. We'd love to have it. Well, so what I thought I'd do with the last part of my time with you is basically maybe share some of my experiences that might help you. So I've kind of given a history, a little bit of how you might know me and things I've done in the past. And I think what might help you most is for you to see how you can personally and literally change the world using open source communities in a similar way that I have. And if I've had any impact, it's only because of the leverage and the power of all these wonderful people in the open source community who helped me. And so I'm anxious to help you to do the same thing and have a really impact on the world. So I thought I'd start by just talking a little bit about some possible answers to questions I've received, even just since getting here. Many people come and say, how do I start? What do I do? How do I jump in? I can give you some suggestions. There may be other suggestions, and there are a lot of different ways to start. I think the first thing is to use search engines, really. I mean, I think open source wouldn't exist today like it does without the search engines. I remember when I first started using Linux in 1994, right? And I wouldn't have been able to make much progress in managing my own system if I hadn't have had a search engine to constantly give me answers. Now we have Stack Overflow for those answers, but Google, Bing, DuckDuckGo, Yahoo, they can still help you figure out, do searches on your interests, and then add Python or to see if anybody's doing something similar to those interests out there. It's a great way to get started. Once you find something you're interested in, then look for issues that are tagged on GitHub. GitLab probably has similar things, but a lot of projects are on GitHub. Look for issues called Help Wanted. Good first issue. Just jump in, look at it, download the code, clone the code, look at the code. Just spend some time. I guarantee you'll have a very welcome community of contributors who love people who are looking at issues and trying to help resolve them. Most projects I know of have a huge backlog of issues, many users, not enough developers, not enough people helping and contributing to those projects. Once you find some issues, quite often you'll look around, you'll see, hey, you run coverage on the code, and you realize there's unit tests and other kinds of tests that can be written. So write those tests. Write those tests, contribute them. I guarantee you'll be very, very loved by the developers on that project. They'll be anxious to have you be a contributor. Contributing examples, another way to get started. Examples are you as a user trying to figure out, okay, how does this work? Let me try it with something and show that example and contribute to the code. Some developer groups love the examples to be right in the repository with the code. Others prefer it to be in a separate repository, and others prefer it to be on your own web page or something. Either way, however you publish it, it's going to be appreciated and going to be valued. So contribute examples. Writing documentation, there's lots of different kinds of documentation. Doc strings, for example, are a great way. You can never become a new user again. So you're doing everybody a service by using your inexperience of the project to help write documentation. Once you learn the project, your future you is not going to understand the problem well enough to write good documentation. So these tools of writing good documentation are critical. Write blogs. If you're passionate enough and interested, this is a great way to build up also other people and collaborators. So blogs can be as simple as, hey, I learned this. There's a great Julia Evans. I remember when I met her, she was very, very new. And it was exciting to watch her progress. She was very new to blogging, very new to the open source community, but she just started to write very transparent, very open blogs about, hey, I don't know this, but I'm going to try. And she became very, very popular because I guarantee there are more people that don't know any concept than know the concept. So you just let people know you're just figuring it out, and you'll have a lot of people who appreciate that voice and appreciate your code. So I have a few more slides here that kind of talk about, and I'll talk about some stories and things that happened to me that might help you in figuring out how to organize your life and organize your thought process in order to really contribute to open source. I think the first thing is actually fixing your attitude, right? Recognizing that actually it's not money or fame or anything else that's going to provide you lasting satisfaction or happiness. It's actually going to be helping people. That's certainly been my experience. Truly helping people. And the cool thing about us is you don't actually have to help all 7 billion people to be happy. It turns out just helping 1 or 2 makes a big difference in your life. And in fact, our brains are such that we don't even recognize our ability to help more than a few hundred maybe. It blows me away. I can't even comprehend millions of people. I know millions of people have been using software I've written, but it's almost like 5 people using it and being happy about it is the same to my brain as 1 million people using it. It's really interesting that way. So you can always make a difference in somebody's life. That's the cool thing. You don't have to help everybody. So in that regard, as you try to help people, you're not going to be completely successful. I certainly have not been completely successful. Sometimes I help people and I make them mad, or I upset them, or they don't like what I'm doing, or they disagree with me. These things happen. And as that happens, it's really important to have a support structure of people that do care about you, that regardless of what you've done or who you've upset or who you've offended. So putting people first, I think, is a great place to start. I was asked once, how do you stay so positive and motivated when you have, when bad things happen? And my answer really is, well, because I've got other stuff in my life that I really care about. I've got my family. So I celebrated my 25th year of marriage this year, and I've got 6 children. That's a lot of kids. Thank you. I'll take that. My wife will take that. I had 3 kids before I started contributing to Python. So my daughter was born the year my 3rd daughter was born. She's the middle one there with the brown hair. She was born when I started to contribute to Python. And what's interesting is I'm actually more proud of her than all the other work I've done, which is a little, it's kind of, maybe I shouldn't be that way. I affected many more people in the world. I should be proud of that. But no, there was a moment when she wrote me a letter. She's away from home, and she wrote me a letter and said, "Dad, I really appreciate you." And it was really touching. And I realized that I care more about that than I care about anything else I've done. And so, look, maybe your experience will be different, but I'm just telling you my experience. So put people first, and then you'll have the stamina and the robustness and the platform and the stability upon which to share with the rest of the world. So deepen those relationships, because those people first, they also need your time, they need your relationships. Okay, so back to actually what are we going to do to contribute to open source? Start with what you care about. Be passionate about something. Be alive. Think what comes alive for you. Think about what makes you come alive, and that's where you should do some work. So I was a young graduate student, and I was really excited about image processing, and I was trying to write C code, and I was doing some Python scripting to do that C code. And the problem I had is I couldn't get data fast enough into Python memory. There was an object called numeric. When I came to Python, an array object already existed. It was called numeric. It was written by Jim Huguenin. Paul Dubois was the current leader of the numeric community. And when I came, I wanted to make it, there wasn't anything to read data from analyzed formats, from my medical imaging MRI formats, into memory quickly. Everything out there that talked about reading data first went to lists of strings or lists of floats. And if you know how Python's organized, a list of lists of floats is a very inefficient structure when you want a gigabyte of data. So I wanted to pull it into numeric with just one header and a lot of binary data really quickly. So how to do that? Well, fortunately for me, there were people in the community who had written about their experiences. A guy named Michael Miller had written something called Table.io, because I didn't know how to write a Python extension. I was new to Python. I didn't know what to do. But I could look at his blog, and he put his code out there, and I could grab his code, and I could go, oh, I can pull that code, and then kind of figure out how to tweak it. And that's where my sort of journey into writing Syfy came from. It came from Michael Miller, right? Still a professor at NCSA in Illinois. His Table.io helped me. The other thing that helped was the essay that Guido wrote. And I've since been able to meet with Guido and talk with him. Wonderful guy, very interesting guy, very smart guy. He wrote this essay about how to do reference counting. Now, most of you probably don't care about reference counting anymore because you use Python or use Numpy or use other tools that take care of it for you. But if you want to extend Python with C code, you have to deal with reference counting to get the memory management right. And I had to do that. And that reference counting essay was critical. So these folks shared their data, shared their information, and I could learn from it. And because I could learn from it, then I could give back. And that's sort of the virtuous cycle that happens as we just do little things to help to take one step at a time to the next level. So I continued doing what I cared about. And what I cared about was writing libraries. I wanted to be able to do my medical imaging research. I was working on MRI and ultrasound data and trying to recover, do signal processing on it. And I wanted to do that more easily. I was writing an MRI simulator, and I wanted to do that in Python. Well, that meant I had to solve an ordinary differential equation and kind of a system of ordinary differential equations, and I couldn't find anything like that. So I went out to the net, and I found there's Fortran code that will do that in ODE pack. Been around since the 90s. So I can grab that and then write an interface to it and then make it available to everybody. And so I just started doing that during Syfy. Now, my wife didn't realize I was delaying my graduation. So we weren't living on much. And she was thinking I was going to finish my graduation and get a job I could actually pay for things. But instead, I was writing code. A lot of people have done that. They've procrastinated what they think what other people are expecting them to do so they could do the thing they're passionate about. Sometimes you have to do that. And I cared enough about it, I kept doing this. And part of the reason was really because the elixir of writing code, sharing it with somebody, and having them give feedback on it. Even just, they paid attention to it. They said, hey, thanks, this is great. And hey, we might do this and this and this. And not just somebody down the street, but somebody across the world. And it's a powerful thing, actually. It's caused me to reflect on, how open source can actually contribute to world peace. As we work together, we can actually understand that we have a lot more in common than we have not in common. And we can work together across boundaries of race, of belief system, to solve hard problems together. And I loved it. And so that continued to kind of help me put energy to write Syfy, and I continued that energy. And that really all the way led to producing Anaconda. Because Syfy really was a distribution, as I said before. And so I had to kind of keep working on that problem for a long time. I think the other lesson is do your homework and participate. When you get started, you're not going to sort of write some new thing that everybody's going to use. That's very unlikely. Most of you will actually make a huge difference by contributing to a package that already exists, contributing to something that's already there. When I started, it was no different. I started, numeric lived was there, but I got started. My wife was, we had this tiny little baby, 3 girls at home. I'm up late at night, effectively writing documentation for the numeric object. I was writing documentation of how to write C code to create new universal functions. They're called ufuncs. So I kind of became the world's expert on how to write ufuncs in Numpy. People still don't care about that problem. But because of that effort, that directly led to my writing Numpy. It was because of that effort I became an expert on the numeric code base. I knew how it worked. And kind of one of the only people that did know how it worked that hadn't left the community and moved on to other things. And so I kind of felt a need, like I needed to write this because I don't know who else will if I don't. Then it also led to Numpy directly because the ufuncs, how do I make them in Python? I wanted to make more universal functions in Python. Now, a universal function, I didn't explain it to those who are unfamiliar. A universal function is a map. You have a big array, and you have a scalar function. I want to do a sine, or I want to add a plus b. That plus, that add operator, a universal function takes that scalar kernel and maps it across the whole array in one fell linear, one swoop, one C++ call, one C call. So you don't have to iterate in Python. You're iterating at the machine level. That's what the universal function did. It's very fast. But to make one, to make a new add, to make a sync function, to make a new kind of universal function, you had to do it in C. And I wanted to do it in Python. That's where Numpy came from. So none of that would have happened had I not done my homework and participated. The other thing I'll talk about is keep an open mind. Follow your interests. Be a little curious. Don't just sort of be so laser focused on the thing you're doing that you don't open your mind and look around and think about other things. So here I was, loving open source, had 3 kids at home. I knew I had to get a job and pay for them, but I loved giving away software. And how is this going to work? How am I going to give away software? I knew about the tragedy of the commons. I've seen it outplayed. I knew about it. How's this going to work? That led me to study economics. Not formally, but I read a ton of literature, a ton of books, just to try to understand how does business work. It directly led me to understanding money, understanding how money works, understanding entrepreneurship, understanding that free societies, it's critical they're entrepreneurs. It's critical for economies that entrepreneurs start new companies. Those new companies are effectively experiments with the marketplace. I learned that money is a coordinating tool. It gets a lot of bad rap. A lot of people love to hate on money and think, yeah, love of money, greed might be a bad thing, but money itself is just a tool. Money itself is just a coordinating tool that lets me cooperate with you thousands of miles away, millions of people I can collaborate with, because money is an exchange mechanism. And truly it's the specialization of labor, the division of labor, specialization, and trade that allows us to have 7 billion people on this planet. It's amazing, actually, and it's how prosperity, it's where it comes from. So learning that was awesome. And I didn't learn it in school, unfortunately. It's really bad, actually, that we don't teach that to more people in school earlier, so we have a correct understanding of how complex systems like economies work. But I learned that, and that led directly. I would not have started a business. I would not have jumped into entrepreneurship. I would not have created Anaconda had I not learned those things while trying to figure out just personal answers to questions I had. So I really encourage you to do that. Keep an open mind. Keep looking around at other things. Keeping an open mind is very important. You also have to learn to listen to critiques. Listen to other people around you that know more than you, because I guarantee someone knows more than you. Someone still knows more than you. Someone still knows more than me. Future you will certainly know more than you do now, today. So be open. Be open to those critiques. Listen to them. Here's an experience. When we wrote Numpy, one of the things we also did was create the buffer protocol. It's PEP 3118. It's very mysterious. Not many people know about it. It led to the memory view object in Python. It's how I became a Python core developer for a time, interacted with the core developers directly. A lot of fun, very stretching. There was a time when I had this D-type subsystem. It's the data type subsystem in Numpy. And I said, this is great. This is the way everything should be. We should have this be the way that you describe memory views. This would be the way we describe the buffer protocol in Python. Well, it turned out that other people felt like the C-type system was better. C-types still exists. You can build data types and complex descriptions of data with C-types as well. So there's this debate on the mailing list about which should be. And of course, I was a fan of D-types because I just built that, and then the C-types folks like theirs. Guido wisely said, well, you know the answer is we're going to punt and just use the struct module. It has an encoding of types as well, so we'll keep that. And it turned out that was actually the right decision because we didn't have a consensus. We didn't really have an answer. We had two opposing ideas. And Guido wisely said, we're not going to try to force one down the throat of everybody. It's actually very important, especially as Python gets bigger and bigger and bigger. The decisions you make at a high level have to be smaller and smaller and smaller because you're likely not going to get them right. And there's going to be people out there who have competing ideas. That's actually what I think about packaging. I think we've gone a little too far in Python with packaging. That what we should be putting in Python is metadata, descriptions of packaging, what should packagers do. But packaging itself is a cross-language problem. It's not a single language problem. So I think we've gone a little too far in our enthusiasm. And those are the kind of things, those are the kind of conversations that have to happen as organizations get bigger and bigger. So it turns out I actually agree with the people that opposed me. Future me is now happy that there are people there that disagreed with me. That's going to happen. It still happens. So be open to critique. Let that, don't run away from it. Don't think you failed because someone disagrees with you. Welcome it and recognize that actually the opposite of acceptance is not critique, it's actually apathy. Like the worst thing that'll happen to you is nobody will care and you'll have apathy. So welcome the critique. Welcome the fact someone cares enough. Learn to write. You're gonna have to write. You're gonna have to speak. You're gonna have to communicate. If you don't, well then find someone on your team who does and make sure they're helping you. I put on there Fernando Perez, who's a great communicator, who helped organize and help really promote Jupyter. And one of the reasons Jupyter is so popular is because of him. Good friend. I wrote a book, Guide to Numpy, not because I love to write. I know it's necessary, but I did it because I was trying to figure out how to fund a graduate student to help me with Syfy. And Guide to Numpy was basically a way, well, I'll sell the book and I can raise some money and I can give it to this grad student. I ended up selling about 3,000 copies of Guide to Numpy before I gave it away and put it out in the public domain. About $90,000. So that was pretty good, turns out. I've heard, it's reasonable. It certainly helped, and I'm so grateful for all those people that bought that book and helped me basically pay for my one graduate student who got his PhD under me while I was a professor. I'm still trying to figure out, how do I help fund Numpy developers? It's still a challenge, and we're still working on it. I've got some ideas that I hope will be coming out next year. And there's other ideas as well. So the other thing you noticed in my life is I've actually gone from one thing to another. And I've reflected about that quite a lot, actually. I've gone, I was working at the Mayo Clinic, I worked at BYU, went to NThought, then I went to Anaconda, now I'm starting something at Quansight. And, all those moves aren't necessarily because I wanted to. Some of the time it's because things were working out. Things were working out exactly, harmony wasn't happening. There were different points of view, there were different concepts. One thing I've definitely learned, however, is even when you're feeling wronged or you're feeling like something isn't going right, don't repay that with revenge. Don't repay that with a sense of, I gotta get back at somebody. They wronged me, I need to get back with them. It turns out that's actually your evolutionary biology tricking you. Like perhaps in the past, that instinct was critical for us to survive with each other or survive in our tribes, but today in an interconnected global world, it just gets in your way. There's plenty more to do. There's plenty more people to cooperate with. There's plenty more to do, and you can't do that if you're harboring anger, vengeance, revenge. So repay evil by doing good. Don't let evil win. I put that signal of disgust up there because interesting neuroscience on this. It turns out, it looks like, according to the latest neuroscience research, is that we are wired as humans to kind of trust people around us until they cross us. Like once they cross us, then it tends to trigger in our minds, in our brains, actually the same neural bodies that get triggered when something's disgusting. So when you hate some food, or you hate something that's just really disgusting, that's the same part of your brain, limbic system, that's triggered when somebody hurts you and wrongs you. So it's not easy to get over this, right? That's a very powerful instinct to kind of, when you're wrong, to kind of push back on somebody. But it's not gonna help you. It's not gonna help you change the world with open source communities because it's just gonna push people away. You gotta break that cycle. You're gonna need a team. So you can't build a team unless people like being with you. And nobody likes being with somebody who's grouchy and entitled or feeling not fun to be with. People like people that are helping them, serving them. We're doing something together. We're accomplishing something great. And you're going to need a team. Now, you don't need a team initially. Together in this room, we're not all going to type on a keyboard and produce some new array interface together. Like you can't have a huge group of people produce innovative things. Dynamically, the interaction profiles, our limited brains can't do it. And this is my experience has been every project I've been a part of that succeeded, it's because there's a small group that does the initial part. 1 to 3 people. And there might be some peripheral people out there who are interested in helping, but there's basically a small team that gets the foundations. But it's really critical for the project to grow that it get a bigger team around it pretty early. And the bigger it can do, and the more people can get around it and promote it and grow it, the better. So you're gonna need that team. That happens certainly with Numpy and Syfy, as I mentioned at the beginning of the talk. Also happened with Anaconda. Early on, there's a small team that was working on Conda and the packaging. And fortunately, that's led to a bigger team in Anaconda and then even a bigger team in the wider community with Conda Forge. 626 contributors producing packages. Should be thousands of contributors. Looking forward to that. You're gonna need that team. And then finally, I wanna talk a little about leadership. When you build that team, someone's gonna have to lead. You are gonna be called on to lead somebody, some group of people. When you're in that role of leadership, what does that mean? Does that mean, cool, I'm in the king's throne, now everybody can bow to me? Actually, if you're a leader and you're not thinking about serving others, then leadership is beyond you. I once heard a story about the CEO of IBM was sitting on a panel and somebody was saying, man, it must be great being the CEO of IBM. Everyone just does everything you want. And he practically fell out of his chair laughing. Turns out, leadership, when you're in charge or you have some responsibility, it's really accountability and responsibility. And it's responsibility to serve the folks around you. There's concepts called servant leadership. There's other ways to describe this concept. But effectively, it's exactly the same thing we started with when I started this section of the talk. It turns out serving, if your attitude is right, that your goal is to serve somebody around you and help them, and you keep developing that instinct, then you have the right framing to go after trying to be a leader. Because then you're going to do the things that help other people, and that's your whole focus. And that's what's necessary to really encourage a large group of people and align them and help them grow and help them connect. Now, my experience with leadership have been, spotty. I've certainly had a lot of opportunity to be in front of people. Numpy, as it certainly grew. I wasn't the leader of like millions of people using Numpy, but people who started to develop on Numpy, that group of people grew to about 5 and 6 and 10 and 15. And as it grew, all of a sudden those people, they wanted, dispute resolution. They wanted to know, hey, we disagree, what are we going to do? There needed to be somebody who was sitting there doing that. Now, I kind of abandoned that BDFL role in Numpy quite a bit earlier than Guido did for Python. I did it not because I really wanted to. Maybe it was good that I did. Maybe it was good for Numpy that I did. But I didn't do it because I really wanted to. I did it because I couldn't afford to take the time to do it. I still had to work 40 hours a week to support my family. I couldn't just take time to work on this open source project. So in some sense, that's potentially unfortunate, but maybe it was lucky break. Maybe it was good for Numpy because Numpy figured out how to kind of resolve those differences and build a governance model that's more community-driven. At Anaconda, growing Anaconda from a small team of 10 people to a large 150-person organization, it tested multiple levels of organizational management. You basically break your company at every scale. As you scale from 10 to 50, that's one set of breakage. Then you do things that work at 50, and it doesn't work at 75 anymore. And then you go to 150, it doesn't work anymore. As we started adding new executive leaders into Anaconda, leaders who could run Anaconda, probably better than I could, and they became, demanding and had to work with kind of political intrigue and them trying to kind of route around me. Those things start to happen. They happen in every organization. All of a sudden, are you ready for that? Are you ready to, and you'll be ready if your mind is focused on the end goal of serving customers, serving people, serving the employees, serving the people that work with you. If it is, then you can handle those situations. So finally, I hope some of those experiences helped you understand that one, you can make a difference. Doesn't matter how far along you are in your journey, you can do something today that makes a difference. And if you keep doing that step by step, maybe not 10 years, maybe it won't take you 20 years, but eventually you'll have a huge impact on the world. And if you leverage the open source communities around you, so let's do more of that. Thank you very much.
Hey, thank you for the talk. So regarding open source contributions, right? So you mentioned GitHub, and there are certain tags like help wanted, for good first stuff. So if there's someone starting in the Python community, is there a way to find out which kind of projects we can pick up?
So the question is there a way to find projects you can pick up?
Yes.
My suggestion is just to really search, do Google searches, do searches on PyPI, do searches on cool Python, or subscribe to Python Weekly. Look for things that match your interests.
Okay.
I mean, there may be other approaches, but that's, I think there is an opportunity for curated lists. I think there's a few of them out there, like Awesome Python. I think there's a GitHub project called Awesome Python. And you can go through there and see if any of those projects are exciting to you. There's some curated lists on things like syfy.org. But ultimately, I think Google has been, in my experience, the best thing to just search my interests, something I'm interested in,
okay,
plus Python, and see if anybody's doing something like that.
Oh, yeah. Thank you.
We have one more here.
Hello. So over here. Yeah. So we are a small startup, India, Cambridge-based, working in drug discovery, and we use a lot of Python to do computational biology. So I'm the founder, and my question is kind of from the different side, that we use a lot of open source work that is produced in Python or in R. As a small startup, what can we do to work with, let's say, the communities who are producing those things? How do we figure out a strategy to work with them and enable them? What should we be doing?
That's a great question. As a small startup, of course, you're still trying to figure out, you haven't really made it yet. Actually, I'd love to talk to you because I have an idea of something I'm trying to produce that could help that situation. We should talk later because it's not fully developed, right? But I think right now, the ways to help are to, one, just give feedback to those communities if you're using their software. Probably have the discipline to let them know, what the use cases that you're struggling with are. Quite often in the startup mode, it's so easy, you're so stuck on the problems you're trying to solve, and you come across problems, but it's a lot easier just to ignore the problem or work around it. Have the discipline to at least write it down, maybe make a note, and then send that upstream, make an issue upstream. That's exactly the kind of area where we're trying to help, kind of be a place people can just shove potentially unfiltered messages, because it takes some work then to give it into an issue that the user community, the software developer community can use it. That's one suggestion, is to have the discipline to use the workarounds. And I think then just, a lot of times those communities can be really good sources of people that might help you, right? So sometimes just reaching out to them, letting them know, and you might make a connection that helps you. Great question. Yeah, and do come talk to me, because I have a concept I'm trying to develop that I'd love your thoughts on.
Yeah, great talk. I had a question on, as a startup, there is always this choice that you have to make whether what I'm working on is a competitive advantage versus whether I should open source it, right? How do you cross that boundary in your own mind as to whether we should keep it in or we should take it out?
It's a good question. So you asked, should software be open sourced when I'm a startup especially? And remember, a business has to sell something. At the end of the day, you're not a business if you're not selling something. Right? And I'm actually one who believes that software can be sold. I just tend to believe that software should be sold on the boundary and infrastructure should all be open source. So I guess that's part of my answer, is what you're doing an infrastructure thing, or is it solving a pain point for customers? That's one answer. I think more practical answer is actually, is the community going to replace this? Like, if you keep it private, is there enough energy going on somewhere else out there in the community that it's going to be open source within 2 years? Right, so if you can tell it's going to be open sourced in 2 years, you better open source it, because otherwise you're going to find yourself fighting against a moving train. So there's sort of the practical answer, and then kind of the theoretical first principles answer of, is this infrastructure or is this peripheral pain points solving? And I actually believe that's a moving horizon, right? But you can sell software on that boundary for 5 to 10 to 20 years in many cases.
Do we have any more questions? Yes.
Hi.
Hi.
So my question was a bit tricky. I always wonder about this. So what do you believe is the relative importance of computer science theory to doing good programming? Because I see a lot of people start coding right away, and I personally feel that theory does play a role in improving the quality and efficiency of your code. But how do you balance between contributing and mastering your theory?
That's a good question. I think the question is basically, how much of your time should be spent learning theory versus practically writing code? Yeah, I don't have all the answers to that for sure. I probably tend to lean more on the applied pragmatic side, but that's not because I don't believe in the theory, because it's very good. Actually, I was writing Numba, and then I went and took Dave Beasley's compiler course, and that was extremely helpful, right? It actually transformed my perspective on how to make Numba better. So I think a combination is usually what I like. Like, get started on something so the theory is something you care about. If you invert it and kind of go after theory first, a lot of times you don't care, and so you don't learn, and then you come away, you might not well have done it. The flip side can happen though too, where you spend years just practically kind of churning on code, and you don't really know why or what it means or how. So I think it's like most things, a trade-off and a mix. And likely everybody can get better at the theory. Like I remember I wished when I was writing Numpy, I'd understand compilers better at the time. I wished I'd understand type systems better. There's so many things I know now because I was a scientist, not a computer scientist. My computer science background came from reading Python source code and interacting with computer scientists who wrote that. And I've learned so much since then. So I really value the learning that comes from the theory as well.
Any more? Yes.
Hello, Travis. Good talk. I wanted to ask question. I just switched from Java to Python 6 months ago. I'm a third-year undergrad. And how can I contribute to the open source community?
You're a third-year undergrad.
Yes.
You just came to Python. How can you contribute to the open source community?
Yes.
Great question. One step at a time, right? So read the code. I think find a project you care about. And if you learn something in school, maybe you just learned Python, how to read Python, maybe you learned JavaScript, maybe you learned C, right? Use that to go and read some code. Like, it's phenomenal to actually go and read the Python source code if you know C. And you actually then understand how it's structured and how it's built. Then to contribute, again, I think the best thing to do is to start where you are and write blogs or write little snippets of examples or just communicate that way. Go to the issue tracker. Every single project has an issue tracker that's just bogged down with issues and nobody addressing them, or not enough people addressing them. You won't be able to address any of them, all of them, but maybe there are some you can look at and go, maybe I can tackle that. And maybe it might take you 2 weeks where it would take an experienced person a day, but hey, that's 2 weeks of learning. And you're helping.
Right. I think we have one last question.
Hi, good morning. Sir, what according to you, when a person is ready to start his own business?
I'm sorry, I didn't quite hear that. When is a person?
Sir, what according to you, when a person is ready to start his or her own business?
Oh, great. When is a person ready to start his or her own business?
Yes, sir.
As soon as you've got the guts. You can start a business anytime, right? You're gonna have to keep learning, but it's just, are you ready to take that risk? Because it is a risk. Happy to talk to you more specifically if you want more detail.
Yeah, hi. You've been talking about trying to get funding for open source contributors, which is a great idea. But so far, open source has been a thing that people do because they love it.
Yes.
And this will fundamentally change the dynamic of open source. What do you think will happen?
Yeah, I think that's a good comment. I think it can. Yeah, I think open source, one of the reasons it works is because it's passionate people who come together because they want to be together. Now, it's already true that people are getting paid to do open source today. We've actually entered a new era with big companies paying huge teams of people to thrust open source on the world. And it's a different kind of open source than the community-driven open source. So we're starting to see that already a little bit. I think, I think that'll change things potentially. I tend to lean on it'll change things we can adapt, as opposed to if we don't do something, we're gonna kind of overrun we're not gonna have maintenance. We're not gonna have the things that we need to continue. We're always gonna be anemic in our ability to fund open source. We can't just rely on the volunteers in order to produce the kind of open source that'll be the infrastructure for all software.